Imagine a bustling apartment complex. It's a self-contained world with its own rhythm. Residents come and go, each with their unique needs and routines. Now imagine this complex operating with the precision and efficiency of a well-oiled machine. That's the magic of Kubernetes, an open-source platform that manages and orchestrates applications, just like a well-run apartment complex. Kubernetes might seem complex at first, but it's built upon relatable concepts. We're going to use the analogy of an apartment complex to demystify this powerful tool. Think of applications as residents, each occupying their own space and relying on shared resources. Just as the complex ensures that electricity, water, and security are taken care of, Kubernetes provides the infrastructure and management for applications to run smoothly. Throughout this guide, we'll break down Kubernetes into digestible pieces. We'll explore the roles of clusters, nodes, pods, and containers, comparing them to familiar elements of an apartment complex. We'll also delve into the control plane, the brains of the operation, and services, the essential utilities that connect everything. By the end, you'll have a solid understanding of how Kubernetes works, its key components, and how they interact to create a harmonious and efficient application ecosystem. So, let's step into our metaphorical apartment complex and uncover the secrets of Kubernetes. In our analogy, the entire apartment complex represents a Kubernetes cluster. A cluster is a collection of resources that work together to run and manage applications. It's the highest level of organization within Kubernetes, encompassing all the buildings, apartments, and residents within its boundaries. Think of a large, sprawling complex with multiple buildings, shared amenities, and a central management office. Each building contributes to the overall capacity and functionality of the complex. Similarly, a Kubernetes cluster is made up of individual machines, or nodes, that collectively provide the resources needed to run applications. The cluster provides a unified view of all the resources available, making it easy to deploy, manage, and scale applications. Just as the apartment complex management oversees the entire property, Kubernetes manages the resources within a cluster, ensuring that applications have the resources they need to run smoothly. Whether it's a small complex with a few buildings or a massive development with numerous towers, the concept remains the same. The cluster represents the entirety of the resources available to Kubernetes, forming the foundation for deploying and managing applications at scale. Now let's focus on the individual buildings within our sprawling complex. These buildings represent the nodes in a Kubernetes cluster. A node is a physical or virtual machine that serves as a worker within the cluster. Each building has the potential to house multiple residents, just as each node can run multiple applications. Imagine each building equipped with its own set of resources, such as electricity, water, and internet connectivity. Similarly, each node in a Kubernetes cluster has its own CPU, memory, storage, and network resources. These resources are managed by Kubernetes and distributed among the applications running on the node. The beauty of this setup is that if one building experiences an issue, the residents can be potentially relocated to other buildings within the complex. Likewise, if a node in a Kubernetes cluster fails, the applications running on it can be automatically rescheduled to other healthy nodes, ensuring high availability. Nodes provide the physical infrastructure upon which applications run in a Kubernetes cluster. They are the workhorses of the system, responsible for executing the tasks and processes that make up an application. By distributing applications across multiple nodes, Kubernetes ensures redundancy and scalability. Let's move into the apartments now. Each apartment within a building represents a pod in Kubernetes. A pod is the smallest deployable unit in Kubernetes. It can be thought of as a single instance of an application, like a self-contained living space within the building. Now imagine dividing each apartment into individual rooms. These rooms represent containers within a pod. A container is a lightweight standalone package that contains everything an application needs to run, including its code, libraries, and dependencies. Each room serves a specific purpose, just as each container within a pod performs a specific function. You might have a bedroom for sleeping, a kitchen for cooking, and a bathroom for, well, you know. Similarly, a pod might have one container running the application's web server, another container for the database, and another for handling background tasks. These containers share the resources of the pod, much like roommates share the amenities of an apartment. Pods provide a way to group and manage related containers, ensuring that they have the resources they need and can communicate with each other effectively. They are the fundamental building blocks of applications in Kubernetes, offering a simple and elegant way to deploy and manage containerized workloads. What keeps everything running smoothly in our bustling apartment complex? It's the central management office, which represents the control plane in Kubernetes. The control plane is the brain of a Kubernetes cluster. It's responsible for making decisions about scheduling, resource allocation, and overall cluster management. Think of the management office as housing a team of skilled professionals who ensure the smooth operation of the entire complex. They handle resident requests, track apartment availability, and address any issues that may arise. Similarly, the control plane consists of various components that work together to manage the cluster. One of these components is the API server, which acts as the front desk of the management office, handling requests from users and other components of the system. It's the primary way to interact with a Kubernetes cluster. Another crucial component is the scheduler, which acts like an apartment allocation officer, deciding which node a new pod should be placed on, based on the resource availability and other constraints. The control plane ensures that the cluster is always in a desired state, automatically recovering from failures and scaling resources up or down as needed. It's the invisible hand that keeps everything running smoothly, allowing you to focus on your applications rather than the underlying infrastructure. Our apartment complex wouldn't be very functional without essential utilities, would it? These utilities, like electricity, water, and gas lines, represent services in the Kubernetes world. Services provide a way to expose applications running within pods to the outside world or to other applications within the cluster. Imagine the network of pipes and wires that connect all the apartments in the complex, ensuring that residents have access to essential services. Similarly, services in Kubernetes act as a logical layer of abstraction, providing a consistent way to access applications regardless of their location within the cluster. They act as a single point of entry for traffic, even if the pods behind the service are distributed across multiple nodes. This ensures that applications can communicate with each other reliably, even if the underlying pods are dynamically created or destroyed. Services play a crucial role in ensuring that applications can be discovered and accessed by other applications or external users. They simplify the process of connecting and managing applications in a dynamic and distributed environment, much like utility lines connect and power the apartments within our complex.